Hey everyone, we are going to talk about energy today. So let's set up our Cornell notes. We're going to line along the side, two lines across the top, and this section over here where you put your name. So I'll put Mr. Will. It is the 9th today, 21. And we're talking about energy. And for our essential question, what are the two kinds of energy? Because there's two categories. Question mark. Okay, so we need to start by figuring out what energy is. So energy, underlined, is the ability to do work. And that means it can change. So let's just put it can change, parentheses. So for example, we could change the temperature of water. That would take energy, and it is doing something, it's doing work and it's causing it to heat up. Or change your speed or direction of an object. And this is measured in joules. Which is spelled a little oddly, but that's okay. Okay, so then we have energy transformations. So transformation means change. So where you're changing from one thing into another. So transformation. Underline. So this is, like I said, it's just one energy changing into another. So, for example, pedaling a bike, you're turning chemical energy from your body into, that's an arrow, sorry, mechanical energy. So it's changing from one kind into another. So kind of neat that way. So one of the two categories that we're going to talk about is kinetic energy. Kinetic energy. And kinetic energy is based on, so it's energy based on how, no, based on motion, based on an object's motion. That could have fit better, whatever. So, for example, if I have a baseball and I throw it at 45 meters per second, that's going to equal about 150 joules. But if I have a car and it's going about 45 meters per second, that's going to be equal to 5,500 joules. And there's an obvious difference between the two, and the difference is the mass, because it takes so much more energy to throw a car at 45 meters per second than throwing a baseball at 45 meters per second. So, obviously, right? So, it depends on mass and, oops, that's a D, speed. Because you multiply those two things together. Okay, and the last one is potential energy. So if someone tells you you have a lot of potential, that means that you have a lot of stored energy. In other words, you're not doing what you should do. Energy. And a lot of this one is based on position, like on a hill. So probably due to gravity. Or it could be based on chemical properties, like a battery. All right. So I think it's time to draw a picture. Okay, so if I have a bike, how do we draw a bike? That doesn't look right. Something's wrong here. Whatever. Let's say that's the bike. That's not bad. Okay. Whatever. So it's going up. Right now, it doesn't have a whole lot of potential energy because it's really low to the ground. So we're going to put in energy. And then that stores it up. Now we have potential energy up here. Oh, I don't have any space. Sorry, it's right there. And then it goes out, and that is going to turn it into kinetic energy because it'll be turned into motion. But let's just say energy out. So now it's stored. And then as we go down the hill, we use that energy and it turns it into motion. And one of the really obvious ones that uses this is a roller coaster. All right, that is your notes for today. I will see you guys later.